This is a preamp kit that I've purchased and is directly coupled. A few things worth noting. It says here the operating voltage is dual AC 12 to 18 volts. Well, that's not strictly true. In fact, it's not true at all. You do in fact need a minimum of 15-0-15 and preferably 18-0-18. It will not work on 12 volts 0-12. It simply won't, because the required DC voltage is 17.5 plus and minus, and clearly you won't get that from 12 volts after it's passed through a regulator. So that's the first problem. Looking down the list, it says it uses 0.1% precision resistors. Well, this comes under the heading of complete bollocks. They are in fact 1% precision, they're 1% resistors. Probably a misprint, but it just goes on and on from here. It mentions the capacitors as being wonderful, and most of them are pretty good. The main smoothing capacitors are in fact Nichicon, so pretty good stuff. But the other ones are largely unknown brands or whatever. It uses NE5534, which is a chip that I like very much, and I've been using those on projects off and on for probably 30 years. And this one, unfortunately, is made by a Chinese special and seems okay, but I'm used to using Texas Instrument ones, which are really good. It uses an ALPS 50K pot, but it is their cheapest one, but seems to be fine anyway. Now, some of the instructions here I'll let you read yourselves, but this do-it-yourself thing here talks about 7 feet and various other measurements and things that just don't make, that whole paragraph really doesn't make any sense at all. And when it says 0 plug adjusted separately for each op amp, output is 0, 6 feet. I mean, does that mean, well, I'm 6 feet tall, so maybe it's okay for me, but if you're only 5'11", well, this preamp is clearly not for you. That's what it should look like when it's finished, and it sort of does. Differences are the red LEDs are in fact green, but that's no big deal. The heat sinks are black anodized, which is better. And apart from that, everything else looks pretty well as shown. You don't get these standoff blocks with the kit, but I've actually added those because otherwise the bottom of the board is scraping along your bench, which is never a good idea. This is sort of the circuit. It's the nearest thing you're going to get, because Chinese distributors are not renowned for their giving away circuits, particularly as in many cases they've stolen them from somebody else anyway. If I sound a little critical, well, yes, I am critical because this is the way it is. A minus point, the PCB has all the component values marked on it, which is wonderful, but once you've put the component on it, particularly the resistors, of course you can't see the component value anymore. So you need to very carefully make sure the right components are all measured and tested before you put them in, and double confirm your soldered joints with a magnifying glass, and I measure all the components, so at least you know if it doesn't work, it's not necessarily something you do, and it's not faulty components. Can't measure the chips, unfortunately. As I said, this isn't the complete circuit. If you see here, there's great batches of capacitors. Now, every stage uses these multiple capacitors, starting with a highish value electrolytic, going down to lower and lower capacitors. The idea being, according to them, which is sort of theoretically true, any noise from any source, for example, the electrolytic will get rid of power supply noise and smooth out the supply, and the ever decreasing capacitors will deal with higher and higher frequencies. Now, I've used these chips many times in the past, and I've never found you need more than one relatively medium capacitor. But this is theoretically audiophile. These sockets on here aren't supplied. They give you a terminal block, screw terminal block, which is actually better, because otherwise you've got to find a plug and some cables to deal with these. Now let's have a look at it in real life.
This is what the preamp looks like when it's all built. The preamp actually requires an AC input of 30 volts center tapped, i.e. 15 and that's precisely what I've got with this little transformer. This particular one came from JCar and is called an MM-2007, and it has a 150 milliamp rating. Now this is rectified and stabilized at 17.5 volts via these two plus and minus regulators. Now I would suggest probably, instead of getting a 15 that you might be better off to go up a little bit and get something like 17 or 18 volts. The regulators run stone cold because they're only just regulating. It does stabilize just about, but there are not, bear in mind there's going to be a volt or two loss on the regulators, and you've only just about got enough with plus or minus 15 volts AC going in. Plus and minus, listen to me. 15 going in, so I would recommend probably a transformer of 17 or 18 volts. Any issues with this? Well, first of all, the instructions, as you've seen on the internet, such as they are completely and totally mind-blowing and don't make really any sense whatsoever. If you're a novice and you're not too familiar with electronics, I would suggest this is probably not the best kit to start with. Just a thought, by the way, regarding the transformer. The load on this is absolutely minuscule. The regulators run stone cold because they're only just regulating, and I haven't measured this, but all the components run cold, and you'll probably find that the LEDs in the power supply probably use more current than the chips themselves, because if you look on Texas Instruments web page, the draw on each of these chips is about 4 milliamps. So literally it's nothing, is it? It's just not drawing any appreciable current at all. So virtually any transformer that can pass 50 or 60 milliamps will be way more than you need. Now, setting this up, as I said from the instructions, virtually makes no sense at all. But this is what I did, and I found it works okay. After assembly, everything was assembled other than the chips going into the sockets, and then there's this blue 10-turn pot here, and there's another one on the other side, which sets up your plus and minus 17.5 volts. And all you do is literally, there's a couple of test points here somewhere, where, there and there. Put your meter on there and adjust the pot slowly, because you've got so much capacitance here. Adjusting the pot, you go way over by a couple of volts or way under, so you have to adjust it a little bit and then wait for the capacitors to discharge, because, as I said, the current drain is so small that even when you turn the power off, the preamp continues to run for about 30 seconds. So as you can see, the current draw is very small, and also this power supply is a bit over the top, to be honest. I mean, there's enough capacitance in there to, well, I suppose you can't have too much. The price of capacitors is relatively low cost these days. Anyway, I digress. Once you've got the power supply set up, you can insert the chips. Just looking at one channel here, this is basically one channel. You have two potentiometers, multi-turn pots, and you have to adjust these so you get zero offset as it's DC coupled on the output. This is the output here. And initially I did this with the volume control on minimum, and I found that whatever I did with these pots, it didn't make any difference at all. In fact, as it came, the offset was 5 or 6 millivolts, which obviously you don't want any DC going into your amplifier. But bearing in mind what I'm connecting this to, the first thing it sees is a capacitor, so unless you have a DC coupled amplifier, a few millivolts here and there isn't really going to make any difference at all. But why have any millivolts if you don't have to? But I found that you have to turn the volume pot on the input right up to full, and then you get offset. But even then it was only about 30 or 40 millivolts. But what I did, if someone can tell me there's a better way or I'm doing it wrong, I'd be delighted to hear, because my knowledge of chips is not that hot. So, but I've learned more on this project than I've learned on anything else so far. Now, the output on these chips is on pin 6, which is 1, 2, 3, 4, this one here. And with the volume on full but with no input, you adjust this pot for 0 DC offset, and then you come down to this pot, this pot here I should say, and on this chip again pin 6 is the output, and the pins are calculated from above, so it goes literally 1, 2, 3, 4, 5, 6, 7, 8. So it's pin 6 here. I've been pointing to the wrong pin, my apologies. But that's pin 6, and that's the output. And you measure the offset here with reference to ground, and that's the left output and the right output, or vice versa, I can't remember which. And just measure it with a millivolt meter. I measured it on the 200 millivolt range, and this channel I've actually got 7 millivolts of output offset on it, and I can't null it in, and it's because this chip, am I pointing to the right chip? No, you can't see it. This chip is not very good. Now, when I used to play with these things as a teenager, they were made by Texas Instruments, but they're now made, or as supplied by this kit, they're made by a company I've never heard of, and I suggest are probably not as wonderful. If you get a chance to change them to proper Texas Instruments or one of the other manufacturers that are producing them, they're probably worth changing, because this one, whatever I do to it, if I swap it to here, the 7 millivolts goes to there and I can't null it out. But in all honesty, I'm not worried about 7 millivolts because it's a very low figure, and as it sees a capacitive input on the amplifier, it's of no consequences. Now I know what you're all asking me. How does it sound? Well, it doesn't sound at all. Now, I know you're expecting to hear such things as, oh, it's got coloured this, or it gives you sibilance, or it gives you something. In all honesty, a preamplifier shouldn't have any sound at all. Well, nor should an amplifier for that matter. But if you've been following this series, you'll know that the amplifier I'm very, very, very pleased with, and has as uncoloured a sound as any amplifier I've ever heard. Now, I know you want to hear it, but it is absolutely pointless me sticking a microphone in front of a speaker or even connecting it directly to the outputs, because YouTube will screw it up and all you'll be hearing is compression of YouTube and the fact that I can't send you out lossless files to hear. But it really sounds good. And one of the questions, diversifying a bit, the kit claims to be 100 watts per channel. Now we know that the Chinese suppliers tend to exaggerate slightly, and they have in the case of this. It depends, of course, how you rate it. The way I rate an amplifier is I take it so I can see visible clipping and then take it back so the clipping has gone. So you're basically still on the low distortion, because the moment you hit clipping, the distortion will rise to 1, 2, 3 or maybe even 10%. Now obviously if you're listening at that sort of level, it will sound awful. So when I say, I haven't got the figures handy, but I think when we measured it before, we were getting 86 watts, both channels driven into 8 ohms. I haven't done any 4 ohm testing because it's irrelevant to me, and I think I would end up blowing the fuses in the amplifier as they're only rated at 2 amps, and I've put them in there because that's my requirement. But I'm sure you will get well in excess of 100 watts into 4 ohms. Now this is actually going to be the last video about this project, for 2 reasons. Partly as the project is 99% finished, all I've got to do in the amplifier now is to tidy up some of the cabling which I'd bodged in there, and put the top cover on, because at the moment it's just laying on there. Things I should mention: I finally got the Alps pot, and I have to say I'm a little disappointed with the pot. Cost me a lot of money, and what I don't like about it, or this particular one, is it clicks. And although the pot is a linear, when I say linear I don't mean as opposed it's a logarithmic pot, but I wanted it to be a smooth rotation, but it's got indentations on it which I don't think I can remove. So although it clicks, it gives you the impression it's a switch, which of course it's not. It's just a notch potentiometer. So that I don't like. The other reason why I shan't be doing any more videos is because of the comparatively few viewing figures that I've achieved. Now I know it's partly my own fault, mainly because my videos are a bit boring and I'm certainly not terribly professional, but also I don't promote the channel. I don't ask for any money from anybody, and people stumble across my channel by accident. So it doesn't justify me spending money to make videos. So this one I put up there solely because this is a project which I've made for myself. I haven't made it for any other reason than the fact that I'm going to use it. Well, regarding the 2 different preamps, I keep diversifying, I'm afraid, but I'm trying to catch up with everything that I've done so far. Now, the valve amplifier does have a sound, there's no doubt about it, and if you're the sort of person that likes things smooth and round, then the valve preamp is very good, but it does have a sound, and I suppose you could say it's the valve sound, and it's the fact that valves are not very good amplifiers. They suffer from all sorts of issues. If you've got, how can I put this, if you've got music that's a little edgy, This smooths that off, and in some cases it can make a fairly poor recording sound a lot better. But that's not what hi-fi is about. The op-amp preamp, as I said to you earlier, does not have any sound. And what I've done, measuring it, there's no point in showing you measurements because it's just flat. When I say flat, it's flat from 3 Hertz up to 100 kilohertz. It's completely flat, and there's no plus or minus on that. It is flat, and it just goes on and on and on. So in terms of frequency response, it's not going to influence the sound at all. You put a square wave into it and it looks exactly the same when it comes out. And I could show you all this thing, but it's pointless. It's just, people say, well, how many dB is it down? It's no dB down, it's just flat. So from as far as the audio bandwidth is concerned, it's not going to lack bass, it's not going to lack treble or anything like that. There's zero overshoot on the square waves. It's got lots of gain. I have to say it's got lots of gain, probably much more than this project needs. But the way I've been using it is to have the gain on the preamp here at about 50%, and then use the pot on the main amplifier to give a good range. But as it stands, it's got way too much gain in many respects. Now, another question that comes up is, can I feed a magnetic cartridge into it? Well, the answer is no. It actually probably has enough gain with them both turned up, but of course it doesn't have RIAA equalization. So it's not the kind of preamp that, if you're into turntables, it's not suitable for that. You would need a preamp with RIAA. It doesn't have any tone controls. If you want to use tone controls, then this preamp again is not for you. But saying that, it has enough gain that there are a number of kits on eBay and the like, that one of them in particular has passive tone controls. And normally you can't use passive controls because they attenuate the gain considerably by 15 or so dB. But this has more than enough gain, so if you wanted to add tone controls between the preamp and the main amplifier, you certainly could. Now here's a look inside the amplifier as a finished project, all but tidying up. Because you'll see here, this is on, by the way, so I don't want to stick my fingers in it. There's a crocodile clip there for earthing, because the Alps pot, ironically, which I don't know if you can see or not, let's have a look. You can just about see it. The case of it, although it's metal, doesn't earth. So I've just got a temporary earth on there. And the same applies, by the way, on the preamp. When you touch the outside of the pot, it buzzes. And so what I'm going to have to do here is to solder a wire to here, to ground. I propose to make or purchase a smaller case than the one the amplifier is built in, of similar dimensions that will complement it, and I shall fit the op-amp preamp in there together with a DAC which I purchased, and also the Bluetooth receiver. Whilst I acknowledge that the Bluetooth is not hi-fi, it will be something that will be useful. Well, I think it will be anyway. My wife tells me it will be useful. So that, I don't propose to do any further filming on this, but that's what I intend to do. And I have to say that the amplifier sound itself is just so colour free. It's just untrue. The switch mode power supply, which I was concerned about, as was one or two of my viewers, is flawless. I can't fault it. It doesn't get any muck on the lines, and there's certainly no sound on the output of any squeaks and whistles, which I was warned would be the case. But saying that, the cost of an analog power supply to do this would have been quadruple or more. So I'm very happy with that combination and would in fact recommend it. Now, going back to power output, one of the reasons any amplifier puts out the power that it does is virtually proportional to the power current available and voltage available. Now, this on load puts out 40 plus or minus 40 volts. Now, there's no way you can get 100 watts into 8 ohms with basically 80 volts. To get 100 watts into 8 ohms, you would need a power supply of probably 100 volts, i.e. plus or minus 50 volts. So the maths tell you that it cannot produce 100 watts into 8 ohms. It will produce 100 watts into 4 ohms easily if the power supply has sufficient current. Now, this one, as you've seen from, if you've watched my previous videos on this, the actual power supply is actually rated at 40 volts, as you can see on that piece of tape there. And it offload, or off on, under quiescent conditions, it's producing 42 volts. But both channels driven into 8 ohms at 85 watts, it does drop to 40 volts, so it's 2 volts drop. And an analog power supply, unstabilized, would drop much more than that, at least 5 or 6 volts. So that's why it won't produce 100 watts per channel. Anyway, that's the end of this recording and the end of this project. I hope the few people that have followed this have found it at least a little bit interesting, and thank everybody that's been viewing and kind enough to say good things. So I'll bid you all goodbye and take care.